I'm going to do the problem Leetcode 1480, running sum of 1D array. So this problem gives us an array. An array is a sequence of, in this case, integers that are contiguous in memory. And we can access every element by the index position that starts counting from 0, right? So the first element of the array is at position index 0. And the last one is at the number of elements minus 1. So in the example here, we got this array nums, and then we're being asked to return another array that whose elements are the running sum at that position so far. So if you have the 0 position, you should take the sum so far, which is just 1. And then the next one, which is the position I, uh, equals to 1, it would basically be the 1 from nums plus the 2, which is 3. So that's what we get. So we basically keep track of a sum so far as we add up the numbers from left to right. So that's the goal here. So we can accomplish this by knowing that we can traverse an array using a loop, for example, for loop, and knowing how to access an element at position I from an array by using this. In this case, I'm going to use Java language, but you can use any language you want. And usually it's the square brackets with the position there. And also we need to keep track of the sum because we're going to do, 1 at first, and then so far 1 plus 2, and then 1 plus 2 plus 3, and so on. So we can use a variable to keep track that so far and use the value of that variable at every repetition. So let's establish the stuff we're going to need. So I'm going to create a variable that's of integer type, call it sum, initialize to 0. Okay, and in this case, they do say there's a return define a running sum array. Although we could create a completely new array and return that, as you can see, the return type in Java is defined before the name of the function here, which is array of int. You could just use the nums itself and replace the values from nums if you don't want to create a new one. So that's totally fine as well. So that's what I'm gonna do, but feel free to create a new array if you wish to do so. So I'm going to make a loop, a for loop that's traditional with 3 parts. The first initialization. So I'm going to make a variable that I call I with the index initialize to 0. And then we have a semicolon separate the parts. And this is an iteration because we need to traverse the array from I equals 0 and then 1 and 2 and 3 all the way to n minus 1, where n is the length or number of elements in the array. So we're going to do like a condition while the I is less. Since we have an array, we're going to use length here. In Java, when we have a primitive array, you can just use dot length. And then semicolon, the third part is the increment because I don't want the thing to keep repeating forever. So I need at the end of the iteration to I plus plus, which means increment the value of I. And then we have some curly braces there. And after doing that loop, I'm going to just return a reference to nums itself. And then we're going to do some processing for every iteration. So in the first time, I is going to be 0. And then we're going to check the condition here. Is 0 less than whatever the num's length is? In this case, in this example, we got 1, 2, 3, 4, right, elements. So 0 is less than 4. Therefore, this is true. We execute whatever's between the curly brace. And then what we're going to do is basically you got to keep track of the sum. So notice we have a variable sum. So we can say that sum, and you take the value that already exists for sum and add to whatever we are seeing now for the current value of nums, like nums brackets at I. So in the first one, nums at I would be 1, right? Because I is 0. And then add to sum would be 0 plus 1. And you can take that and replace the value of sum by reassigning the equal sign like this. Some people like using shorthand notation. This is equivalent to the plus equal like that. And because of Java, I need a semicolon at the end of the line. So basically, it's going to keep a running sum, right? So it's going to be First sum is going to be 1. The next iteration, as we increment I is going to be 1. And then we're going to do nums at 1, which is basically the number 2. We add that to the 1 that we had, so it's 3. And then so on and so on until the end. Notice the condition would have been when the I would have equaled the num's length. That in that case, this is false. It would exit the loop. But notice we haven't changed nums yet, so I want to keep track. Replace whatever's in nums after having used nums that I'm going to replace that value so I can reassign with the actual sum so far, semicolon like that. So like I said before, you could have created a new running sum variable and assign to that instead. You could do that, running sum at I. But I prefer just changing plates here so I don't have to use space complexity of ON. And yeah, let's check it out. So we got some cases seems to be running. As you can see here, if you're given sequence 1, 2, 3, 4 for nums, we are expected to get a new array, right? An array that has the running sum so far. So if I start 1, that's just 1. And that 2 is 1 plus 2 is 3. That's correct. And then so far 1 plus 2 plus 3 is 6. We got 6. And then 1 plus 2 plus 3 plus 4. So it's basically the previous sum of the previous one so far plus the current one, which will give you 10. And if I submit, that should do the job. And there you go. So I'll comment on the complexity of time and space. In terms of time complexity, because we have to traverse every element of the array, let's say there's n elements, the order would be O of n. And for the space complexity, since I'm not creating a new variable, a new array, I just have the sum variable itself. So it's basically constant to space, so O of 1. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right, thank you so much, and I'll see you in the next one.